have 24y to the fourth minus 54y cubed. Now, the only way we can have a greatest common factor is I need to be able to pull something out of both items. Numbers are easy. Numbers, you can always pull at least one out. So numbers are never the thing that prevents me from factoring something. It's always the variable. And I have to be able to at least pull out a variable, the same variable out of each of them, which means y must appear in every single term. So when I'm looking for pulling out the greatest common factor, I must have a y in all of the terms if it's in one of them. I do. I can pull out at least a y out of there. So that means I can factor something out. So before I get to the y's, because I know y's are going to work because I have y's and everything, the first thing I'm going to do is, what's the biggest thing I can pull out of 24 and 54? So I'm looking for that biggest number that will go into both of those. Going with 6. Sure, we'll check it. We'll check it. You'll figure it out if you get it right or wrong when you, yeah. All right, what's the biggest thing I can pull out of y to the fourth and y cubed?
Y cubed.
Y cubed. You can always pull out the smaller power. You can always pull out the smaller power. Because remember, when you're doing your multiplication and division, you're either adding or you're subtracting. So now when we pull out our y cubed, now we could talk about this a little more fully when I factor something out. So first of all, when I factor out 6 out of 24, you're just dividing. You're doing 24 divided by 6, which I'm pretty sure is 4.
Yes.
We're good with that? All right, now we're going to divide y cubed from y to the fourth. And when we divide, we subtract. So I'm going to have 4 minus 3, which is going to leave me y to the first. You can write it. If that helps you, just write what? I'm sorry. Yeah, no, we're good. Y to the first. Okay. Then you told me 6 goes into 54. I bet you it goes in 9 times. Now when I do y cubed divided by y cubed, it turns into y to the 0th because you subtract. 3 minus 3 is 0, which is not nothing. It's 1, but we don't write it. Yeah. So it's really just 1. So I'm just not going to write it. So we just have that. Factored. You just got factored, son. All right, we got numbers, so we could factor something out of there. I have A's in all of the terms, and I have B's in all of the terms, which means I can factor out a number, I can factor out an A, I can factor out a B. All right, 51 and 17. Does anything go into 51 and also goes into 17? 17, baby. All right, so we're going to have 17. A to the 8th, A to the 3rd. What goes into A to the 8th, and A to the 3rd? Don't add them. A to the 3rd. We always pick the smaller one. Yep, so A to the 3rd goes in both of them. All right, I have B to the 4th. I have B to the 5th. I'm going to pull out B to the 4th. Always the smaller one. Now we're going to go, okay, 51 divided by 17. That's all factoring out is divided. You can just plug in your calculator. 51 divided by 17. That's going to equal 3. Now we just take A to the 8th divided by A to the 3rd. We subtract. 8 minus 3 is 5. So we have 8 A to the 5th. B to the 4th divided by B to the 4th is just 1. So I don't write anything for B. B's already taken care of. Then we have plus. You can write a 1 there if you want to, or you can leave it blank. Because we know 17 divided by 17 is 1. I'll leave 1. You don't have to. These are your notes. A to the 3rd divided by A to the 3rd is 1. Not going to write another 1. B to the 5th divided by B to the 4th is going to be B to the first. And you don't have to write the first either. I have 2 1s that I don't need to be there, but there's no reason why you can't have them there. I'm not going to take off points because you have a 1 out front or a 1 as power. Greatest common factor. Can we do that? I hope so. All right, the next thing we're going to talk about is difference of squares. When we get to difference of squares, we should recognize at least some of the squares. And when I talk about perfect squares, I'm talking about 1 times 1 is 1. Another perfect square is 2 times 2, which is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. You might go up to 121. You might do 144. You might do 169. But honestly, when you start getting up there, you're less and less likely to memorize those. A good bet is if you think it's a difference of squares, just plug it in your calculator. If I tell you to like factor this, you're like, ooh, I got a square here. Let's check if we should know 25 has a square. But if you're not sure, if it's a big number like 169, just throw in your calculator to see if it's got a square. Now, in order to do a difference of squares, here's our rule. Our rule for factoring a difference of squares is if I have a squared minus b squared, I feel like we did this a lot, didn't we? That should equal a minus b times a plus b. But that means, now, these placeholders are something squared minus something squared. Don't look at them always having to be a number or just one variable. It has to be something squared minus something squared. That's going to be important for some of these. Because if we look here, I have 36w squared. I need to write this as something squared. I don't have something squared. I got something times something squared. I need a quantity squared in order to use difference of squares. And what I mean by that is I need to write this as basically, I'm going to write parentheses. I'm going to say I need something entirely squared minus something squared. Sometimes that something is as easy as putting a 5 here. Because this would just be, 25 squared is just 5 squared. I can write that as 5 squared. That's not a hard thing to do. The hard thing is to recognize is that this expression right here, I can write with the squared above it, the entire expression. Because 36 breaks down into 6 squared. So I can write 6 here, and I'm going to write 6w. Because remember, when you're squaring something, that square basically it's not the right term. It kind of gets distributed to everything if it's chained by multiplication. So 6w does equal 36w squared. Yeah. So now I have something squared minus something squared. This something goes in for my a's, all of my a's, and this something goes in for all of my b's. So it's going to look like this. We're going to rewrite this as my a is 6w minus my b, which is 5, times 6w plus 5. Now, I know we've done plenty of difference of squares. We haven't really done anything like this, though. We did a little bit when we did that to the 4th power, and we had something squared. But we just need to understand that I need something squared minus something squared. So if I have something like this, 144. Anyone know what the square root of 144 is? 12. So that means that 1 over 144 is going to be 1 over 12 squared. I'm going to once again use parentheses. You don't have to. This is just how I would teach it when I start teaching it. If it makes sense to you, use parentheses. I love parentheses. It just tells me that thing's being squared. Now for the next thing, I need something and something squared. Now remember, when you raise a power to a power, you multiply. When you raise a power to a power, you multiply. So I need r to something when multiplied by 2 gives me 6. I need r cubed. I need r to the 3. And I'll write that down and explain that again. So r to the 3 is really r cubed squared. r 3 times 2 would give me 6. So I'm going to have s to what power then? I'm going to have s to the 2nd power. Because 2 squared would work. Now, this is my a value. This is my b value. I don't care what it is. It could be smiley face, table, whatever. You plug it into this formula. My a is 1/12. So I should have 1/12 minus my b value is actually this r cubed s squared. So we're going to have, this is going to equal my a value is 1 over 12. Minus my b value is at r cubed s squared. And then I'll have 1 over 12 plus r cubed s squared. Do we have questions on that? It's an easy but kind of difficult concept at times. It's hard to kind of see how it goes. Kind of just takes a little bit of practice. All right, I'll do this one really quick. All right, 16. So 16x to the fourth. I need something squared. Bless you. What squared gives me 16? 4. All right, x to what power when raised to the 2 is going to give me x to the fourth? It's going to be x squared. The reason why I picked out this one, I need something squared and it has to equal 1. What has to go in that parenthesis? 1 has to go in that parenthesis. So don't forget about that. When you're doing difference of squares, 1 is a perfect candidate to be a perfect square. All right, so that means I have my a value. So I have my 4x squared minus 1 times 4x squared plus 1. Did I do anything wrong?
No.
There's a huge mistake on there.
You didn't do the rule for factor.
It's plus.
Oh. I'll put some more apostrophes on there. Can't do it.
You can't do it.
It's fully simplified.
Use double.
It's fully factored. Because the only thing I factor out is a 1. That doesn't have x's in it. So all of that work on a quiz or something like that would be for naught. Because this is exactly what I'm going to do. I'm going to cross it and I'm going to put no. It's difference of squares, not adding. My goal is not to put like a bunch of them or anything. I'm not trying to trick anyone or anything. But you will get to times where you have to like reduce something, and it'll reduce to something that looks like it's a difference of squares. Just remember, difference of squares has to have a subtraction between them. So all that work was for naught. All right. Last one. All right, so I need something squared minus something squared. Why don't you go ahead and handle that for me? Do it on your own. You need something squared minus something squared. If you get through the whole thing, awesome. Did you get it? Doing okay? All right, for my A term, I got 3a squared b squared. Does that look right? Good so far? Okay. And then for my b, I got 10c, all that squared. That's okay. And then we just go ahead and plug it in. So I'll have 3a squared b minus 10c, 3a squared b plus 10c. Doable?
Yep.
All right, yeah.
What if it was plus 100C?
You would say
Oh, shoot.
no. We put no, and the reason why we can't factor anything out is because I can't factor an A, can't factor a B, and I can't factor a C because we don't have both of them in there.
Okay.
You could maybe pull out, nope, there's nothing you can actually pull out of both of them. So that's just another, no. Don't be stupid, Mr. Pabian. It's got to be a difference of squares. The trouble comes in when we get to cubes. Cubes have a sum of cubes formula and a difference of cubes formula. Yeah, I know. It's good. It's good and it's bad. All right. Perfect cubes. Perfect cubes kind of less recognized. 1 cubed is 1. 2 cubed, 2 times 2 is 4, times 2 is 8. 3 cubed, 3 times 3 is 9, times 3 is 27. 4 cubed is 4 times 4, which is 16, times 4 is 40, plus that'll be 64. 5 cubed, 5 times 5 is 25, so we have 125, and so on and so forth. Really, if I tell you to use difference of cubes, there must be a way to take the cube root of it. And you can just plug in your calculator and just double check. Okay, rule for factoring sum of cubes. Sum of cubes is a weird, and I'm going to double check that I got this right. So let's say I have x cubed plus y cubed. You can write that out as x plus y times the quantity x squared minus xy plus y squared. I'm just going to double check. Sometimes I miss my pluses and minuses up. Nope, we got it. X plus y times x squared minus xy plus y squared. I'm going to skip to the rule for factoring if it's a difference of cubes, just so we can see they're very, very close. Just small changes. I'm going to go back to this slide. Perfect cubes, we already did those. I don't know why I wrote it twice. Stupid. All right. So the rule for factoring a difference of cubes would be if I have x cubed minus y cubed. X cubed minus y cubed is going to start out as x minus y. I like how this starts because plus starts with plus, switches to minus, and goes back to plus. If it's minus, we're going to start with minus. We're going to switch over to plus, so it'll be x squared plus xy, and we'll switch back to minus to give us y squared. So realistically, the only difference between me doing this problem and that problem is my negatives and positive signs. So this might be the only thing we haven't really seen before, that we kind of have to kind of memorize that little formula. We should know a squared plus b squared equals c, or a minus, I just got out of geometry class. We should know a squared plus b squared equals c squared, but we should also know that a squared minus b squared equals a minus b times a plus b. This is the only new thing on here. All right, let's do a couple problems with this. We might not do all of them, because why? All right. So I have h cubed plus 125. Now remember, in order for it to be a difference of cubes, there must be a way to write this as something cubed plus something cubed. Our job is just to figure out what something goes in there. Well, the first one's already done. It's h. All right, 125 looks like that's going to be 5 cubed. Hey, your scientific calculators and specifically your graphing calculators can do cube root for you. So you can check on your calculators. And if you're not sure how to do that, ask me. They're hidden in the math button sometimes. Like if you hit the math button, you can do your cube roots and stuff on there. You're gonna hit that math button first, and you're gonna put the cube root button. You're gonna hit that first.
Wait,
so
can I just do 3 and then can't I just do
yes.
like
Yep.
3 and then that and then
Yep. Some of you has a dedicated one, some don't. But if you need a fourth root, that's when you go to your math. It's nice to know where those things are. Okay. So now we just have to plug in the formula, make sure we're using the right one. So we're gonna go. Well, that's going to be h plus 5 times h squared minus, I know it's technically for the formula h5. I'm going to switch around to be 5h. And then it's going to be plus 5 squared, which is 25. I might put a little note there and saying that's 5 squared to remind myself that it's h squared and 5 squared at the end. Uh, 8, 9, or 10, which one would you prefer to do? I'm just going to do one more.
one's harder.
I don't know. You decide. I think they're all equally difficult.
Maybe the last one.
Want to do the last one? Okay, let's do 10. Now remember, we need to write this as something cubed plus something cubed. So here might be a good time. 729, that's a weird number. Maybe I plug in my calculator and see if it's got a cube root. Does 729 have a cube root?
Yep.
What do you got? Got 9. So that's just, isn't it easy to use a calculator? Like, rather than like doing it in your head? You actually have a cube root button, or you can go to math. So you have 2 ways to do this. The first way you can do this is, oh, yours doesn't have it. Some have a dedicated cube root. So we'll just go to math, and right here is your cube root. So some of them have that dedicated one. Got it? All right, what do we, 9? Yes. So we have 9. And now remember, for m, I need m to some power when multiplied by 3 gives me 6. M, yep, squared. M squared, because 2 times 3 gives me that 6. So the only difference is now I have to divide this by 3. All right, 64, does that have a nice cube? Yes. Yeah, it's got 4, right? And then n to the first. Because n to the first, 1 times 3 is 3. All right, that's my a value, that's my b value, or my x value and y value. So this is just going to be the first thing, 9m squared plus 4n. Times the quantity. Here's where you might want to do a little side work or actually put it in there. So I'm looking at that space right there. That right there is supposed to be 9m squared because we square them to put them there. Are we okay with that? I see a little confusion. Okay, so remember, we take whatever this first term is, whatever this is, and we have to square it to put it here because we have x squared. So whatever this is has to be squared to go there. So we're going to have 9 squared, which is 81. So we have to square both things. So if I look at 9m squared, I have to square both things. Okay, 9 squared is 81. M squared squared is 2 times 2, which would be m to the 4th. All right, to get this middle term, and a good thing I left that little space there. Let's do the middle term. The middle term is both of your terms multiplied. So what goes there is going to be 9m squared times 4n. I can multiply the 9 and the 4. That's going to give me... Do you guys have this problem on yours? I'm just double checking. Okay. I was pretty sure I canceled some out, but I didn't. All right, so that's... What was that? Oh, no, we'll have 36
I thought it was supposed to be minus, though.
m squared n. Yeah, we should have a minus. Sorry, I got bogged down in explaining that first part. So that should be a minus. But this we can figure out. But does this make sense? Yeah. So I need to square the first thing to go here. I need to multiply both items to get my middle term. Yeah. Yeah. And then I have to square the last thing for the last term, and that is a plus. And we're going to square that last thing. Our last thing is that 4n, so I need to have 4n. Remember, it's quantity squared. Don't just put a squared on there. We have to do 4 squared, which will be 16. And n squared will just be n squared. When it's practice, it's not hard. Because a lot of the stuff you could do in your head if you know what's going on. If you don't, write it down. Don't speed stuff up. Write down all of your steps until it gets locked in your head. Because when you're good at it, I just know that this has to be squared, so it's 81m fourth. You don't have to do this. I've done this a lot of times. You don't have to be where I'm at. You shouldn't be, most likely. If you are, awesome. Good job on you. Write stuff down like this, like point to this. Oh, I got to square that whole thing. Oh, that's 81. Do we have questions on that? Here's a good thing. We're going to do 2 more, but with the subtraction sign. The only difference is we're just going to switch up our pluses and minus, so we'll have a little bit more practice with it. Do we see 2 of these we really want to do? No? Okay, we'll do the first one then. All right. What was that? And you want to do the 1,000 one? Okay, let's do the 1,000 one. All right. So I need to write this as something cubed minus something cubed. Well, the nice thing about 1,000 is it must be 10 10 times 10 is 100, times 10 is 1,000. All right. And then we need m to the, what power when cubed would give me m to the first? Yep. M to the first. All right. M to the first cubed would give me m cubed. All right. Oh, this will just be 1 cubed. Because what's 1 times 1 times 1? 1. So anytime we have a 1, that guy just goes in there. So we just have 1 cubed equals this 1. All right, this is my a value. This is my b value. This is my x value. This is my y value, however you want to look at it. So when writing this out, we're going to have our a value minus our b value. So this would be 10m minus 1. Now our first term is that a value, that 10m, and we're going to square it. So we have 10m squared. This is important because sometimes we just tack on that squared. We need to remember it's 10 times 10, which gives me 100. So that's going to be 100 m squared. Then we need 10m times 1, which is just 10m. I am going to write it underneath because it's always good to just know where stuff came from. So this is 10m times 1, which is just going to be 10m. And minus turns into plus 10m. And then we'll have minus, that'll be our last value squared. So that'll be 1 squared, which just equals 1. And now I'll go back and check. Minus plus minus. Yep, that's right. Should we do one more? Totally cool with it.
Yeah, let's do it.
Let's do one more. Should we do that last one?
Yeah.
All right. All right, we'll do the very last one. All right, so remember, we need something cubed. This one's easy because it must be p cubed. Minus, is 216 a perfect cube?
Yes.
6. All right, so we'll have 6, and it looks like we're just going to have q cubed. Because q to the first to the third is going to give me cube. All right, we start off by subtracting our 2 values that are in those parentheses. So I'll have p minus that 6q, no work required there. Then we have to switch over to, as a reminder, we need to square the first thing that's in parentheses. So that'll be p squared. So we're taking p, we're squaring it, and that just turns into p squared. Then we'll have plus. Our next one is our second parenthesis, which is 6q squared. Nope, we're multiplying them. So I'll have, let me put that back in order. So we're going to have p times 6q goes there because we multiply the 2, which will give me 6pq or qp. It doesn't matter what order you put it in. 6pq. Then we have a minus sign. And now is when we take that second parentheses, got 6q in it, we're going to square it. So I'll have 6q squared. 6 squared is 36. Q squared is just q squared. And we are done. I think this is the hardest stuff because we might not have ever done this.
Yeah, that might be, yeah.
And I think the hardest part is understanding that you're squaring the entire thing that was in that parenthesis. And you're not just tacking a squared onto it. Hopefully it feels at least doable. I'm not overloading anyone. Because we're going to move into factoring. More factoring. Trinomial factoring. I think most of us, looking at our tests and stuff like that, we know we have a method to factor.
Yeah, that they make you do.
Yep. I'm going to do that. I'm going to do the factor by grouping. Factor by grouping is nice because it's the only way to do, these will be super easy if you know factor by grouping. So I'm going to do factor by grouping on these two. In particular, I want to do both of them because they're slightly different. So our first one, d squared minus 13d. Okay, we have a trinomial. Perfect time to use factor by grouping. I said my method for factor by grouping is doing an air conditioning Beyonce column. I do my A times C and my Beyonce column. A times C is going to be 2 times negative 7, which is going to give me a negative 14. B is just a negative 13. My job is I need two numbers that multiply together to give me negative 14, but when added, give me a negative 13. Do those two numbers exist? 14 and 1.
Yeah.
Now we've got to make sure we do the right ones. So either it's going to be a negative 14 and a positive 1, or it's going to be a positive 14 and a negative 1. Well, it must be this first one, because I need negative 14 minus 1, or I'm sorry, plus 1, because it's a positive 1, is going to equal a negative 13. So we have negative 14 and 1. Now, the cool thing is, the whole idea of this is I just need to split that middle one apart. Just need to split that middle one apart. So instead of negative 13d, I'm going to write it as negative 14d plus 1. So we're going to have 2d squared minus 14d plus 1 d, or we can just write d. It's up to you. I'll put 1d minus 7. Factor by grouping says look at these as a binomial plus a binomial and factor out the biggest thing you can out of both those binomials. So 2 and 14, I can pull a 2 out of there. D squared and d, the smaller power is d, so I can pull a d out of there. 2 divided by 2 is 1, so we're just left with a d here. 14 divided by 2 is going to give me 7. D divided by d is 1, so I have d minus 7. I picked this one particularly because you should at least try to factor out a 1. So when I look at d minus 7, the only thing I can factor out is a 1, and I'm going to factor out that 1. I'm going to factor that out to being plus 1d minus 7, because what's in parentheses must be equal to each other to do the next step. The next step is smooshing together that 2d plus 1. And this will be my second binomial. So this is just going to equal, 2d plus 1, and then d minus 7. That's it. That's factor by grouping. It's not a hard process as long as you just know what steps you're doing and why. All right, there's nothing special about this one except for, notice how we have g to the 4th, g squared, and then nothing. This is the exact same process. It only works if you're dropping by the same amount of powers. Dropping by 2, I can do factor by grouping. So because you're dropping by 2, because this is actually g to the 0, I can do factor by grouping just like we did over there. So it is okay as long as it goes 4 to 2. If it went 4 to 3, I couldn't. If it did 5 to 1, it couldn't. It's got to go 4 to 2 in order to use factor by grouping. Otherwise, we can do factor by grouping. We can do our A times C, our Beyonce column. A times C would be 10 times 9, which is 90. Our B is 21. I think the hardest part about factor by grouping is this step. What can I multiply to make 90, but also adds to negative 21?
33.
What was that?
33.
30 and 3. I don't think that's going to work.
Oh, wait. Oh, no, that's...
Make sure we're all working on this. Six and 15. 6 and 50, yep. So we have 6 and 15. 6 plus 15 equals 21. So I'm just going to tack a negative on in front of both of those. It is negative 6 and negative 15. That works. So we're now going to have, now the next step should be pretty easy. We're just going to have 10g to the 4th minus 6g minus 15g plus 9. Factor out the biggest thing you can out of these two, and then factor out the biggest thing you can out of these two. 10 and 6, I bet you can pull a 2 out of there. I can pull a 2. Oh, hang on. Stop. I'm going too fast. These should have been g squareds. Those should have been g squared. So I'm splitting apart 21g squared, so I have g squared there. So I can pull a g squared out of there. I can pull a 2g squared out of there. That will leave me with 5g squared. 6 divided by 2 will give me a negative 3. G squared divided by g squared is just 1. I'm going to run out of room pretty quick. I'm going to go ahead and write smaller maybe. All right, the biggest thing I can pull out of negative 15 and 9, you do want to pull out the negative version of it, because negative 15. So I'm going to pull out a negative 3. I'm going to erase this so I have room. And that's going to give me a positive 5g squared. 9 divided by negative 3 is going to be a negative 3. And our end answer is going to be 2g squared minus 3 times 5g squared minus 3. I'm just going to do one of the next ones because we've already done it twice. You'll see on test, I'll put factor this. The only people that are going to know how to do this are people that know how to do factor by grouping. If you have 4 terms, the whole point of factor by grouping is to turn it into 4 terms. This is, I already gave you 4 terms. So basically I'm starting at this section right here where I just have to go, to factor by grouping, I need to have a binomial plus a binomial. Factor the biggest thing you can out of both of those. Either it works or it doesn't work.
And if it doesn't work,
It doesn't work, you could say, Mr. Pabian, I don't think this one works. You can ask a question, or it's as factored as it can be. Okay? All right, so we have 2 and 3. I can't pull anything out besides 1, but I have h cubed and h squared. I can pull out the smaller one, which is h squared, which is going to leave me with 2h cubed divided by h squared. 3 minus 2 is h to the first. Minus 3, h squared divided by h squared is 1, so we just have a negative 3. Looks like a 6 and a 9, I can pull out a 3. So we have plus 3. 6 divided by 3 is 2h. Minus 3. I know it works because what's in the parentheses are equal to each other, so I can smoosh together that h squared and that 3. H squared plus 3 and 2h minus 3. I will reiterate the fact that I don't care how you factor on these first 2. If you do like the snowflake methods, you put that little cross and you put your numbers in there, I don't care. But you should understand factor by grouping because it's the only way that 17 is going to work is if you know that factor by grouping, how to do 4 terms and turn it into a binomial times binomial. Questions on that? That's pretty much it. I know I have some more problems down there, and I'll do one of them.
These are the same.
These are everything put together. Let me see if there's one I particularly want to do. It reiterates the fact that sometimes it's not just one problem, it's multiple different things. Let's do, you want to do 21? Okay, we can do 21. 21. So here's what you need to look out for before you start a problem. If I tell you to factor it, the first thing you want to look at is there something you can just factor out first? Is there a greatest common factor to make the problem easier? So let's go back to that problem. I think you said 21, right?
Yeah.
Now, my job is to look at, okay, I can't factor out a number because I have a 1 here.
Mm-hmm.
Okay. Can I factor a j out of everything? I can.
No.
Nope. Can I factor a k out of everything?
Yeah.
See how there's a k that exists in all 3 of them? Because there's a k that involves all 3 of them, before you start, you need to factor this out. In fact, this problem doesn't work until you realize that there's a k in all of them that needs to be factored out. So now we're going to go ahead and we'll say, okay, that's k times j to the 4th plus 3j squared minus 28. And now it's just a factor by grouping. We already did a bunch of those. I'm just going to put a dot, but you're going to end up with k times Oh, I guess we should do this one. I lied. We should probably go through this one because this one has an extra step in it. It does have an extra step in it. So let's go ahead and factor this one. Factoring it, factor by grouping says do my air conditioning is a good one to pick out. And Beyonce. Air conditioning is 1 times negative 28, so that's negative 28. My Beyonce is 3. I need two numbers that multiply together to give me negative 28, but the difference between those two numbers is 3. 7 and 4? All right, 7 and 4. We probably want the 7 to stay positive, so I'll have 7 and negative 4. Okay, that's going to give me k times j to the 4th. We're going to split this apart into plus 7j squared minus 4j squared minus 28. I'm going to skip a little bit because I think we could do this. I have faith in you guys being able to do this. I'm going to skip down to this would just equal, if done correctly, k times j squared minus 4, j squared plus 7.
Okay, so that's just the normal.
That would be normal, just our normal stuff.
Yeah.
But I do want to point out something that can happen because everything's fair games in these. J squared minus 4. J squared minus 4. J squared minus 2 squared.
Oh, so I can take out
J
2.
squared minus 2 squared. A squared minus B squared equals A minus B times A plus B. This right here is a difference of squares, so we can factor once more. This is a difference of squares. This is j squared minus 2 squared. So we can rewrite that as j minus 2 times j plus 2 times j squared plus 7. So we have to go that one extra step. I just want to point out that extra step because you might do the work and look at the answer key, and the answer key might have a different answer. So you might have got up to here and said, oh, the answer key's wrong, Mr. Pabian. Just double check that I didn't use like a difference of squares, difference of cubes, sum of cubes. So it's okay if you catch this on the answer key. This is why we check the answer key. Just check to see if your answer is different than mine because you missed that I could be factored even further. So this was a good one to pick because we had to factor something out. We factored it, and we had to factor it again. Those are the hard ones. Questions on anything we covered?